Hello and welcome to this video on calculating weight. We're going to use this equation W equals m times g, where W equals weight, m is mass, and g is gravitational field strength. Now again, you're lucky enough to get this equation on your equation sheet. Here you can see you've got the letters for the equation and over here what they mean. So you don't have to remember that W equals weight and m equals mass and g is gravitational field strength because they are already on this sheet. What you do need to remember, however, is the units that these three are measured in. So we need to remember these off by heart, that weight is measured in newtons because weight is a force. Mass is measured in kilograms and gravitational field strength is newtons per kilograms. So gravitational field strength is different on different planets. Gravitational field strength on Earth is also different from the gravitational field strength that exists on the Moon. On Earth, the gravitational field strength is approximately 10 newtons per kilogram, whereas on the Moon it is approximately 1.6 newtons per kilogram. And this is really important because this will help us explain the difference between mass and weight. So if I had a man on Earth, okay, and versus a man on the Moon, I suppose if we actually draw it on the object it might help. So we've got a man on the Moon and a man standing on the Earth. If it was the same man, the mass would stay exactly the same. So if this man had a mass of 70 kilograms on Earth, he would also have a mass of 70 kilograms on the Moon. The mass does not change. Mass is the amount of stuff that you're made out of. So if you go from the Earth to the Moon, you're still made out of the same amount of stuff, so your mass does not change. If you're 70 kilograms on Earth, you'll be 70 kilograms on the Moon. What does change, however, is your weight, because your weight, if you look at the equation, is dependent on your mass and the gravitational field strength. We can see that on Earth the weight would be 70 kilograms times the gravitational field strength, which is 10. So his weight would be 700 newtons. Whereas on the Moon, his weight would be 70 kilograms, because that's the same mass still, multiplied by 1.6. So his weight on the Moon would be 112 newtons. So his mass is the same, but the weight is different. So the mass does not change, but the weight does change. Because if you remember, we said before the weight is a force, that's why we give it the units newtons, and the weight is the force with which that man is being pulled towards either the Earth or the Moon. So we can put a arrow on here to represent the weight. It's the weight with which he's being pulled towards the Earth, or the weight which he's being pulled towards the Moon. And on the Moon, the weight is a lot lower, but the mass is the same. On the Earth, the weight is a lot higher, and the mass is the same. That's why you'll see videos of astronauts on the Moon taking large bouncy steps because there's less force pulling them, and that is why their weight is lower. Now in everyday language we use weight in a different way. If we talk about how much you weigh, we're really talking about our mass. Okay, so Americans tend to talk about their mass in the correct way. I have a mass of 70 kilograms, for example, whereas in England we tend to talk about that being our weight. I weigh 70 kilograms, or I weigh 50 kilograms. That is wrong in terms of physics. You must get your head around talking about anything in kilograms being mass, and weight specifically describing the force with which you're pulled down to earth, and that being measured in newtons. So for example, if you've seen force diagrams before, you might see gravity as the downwards arrow, okay, and that's fine to write that, but it's actually better if we just start describing this downwards force as weight, because we need to take into account the mass of the table and the gravitational field strength. So rather than gravity, you might see the word weight pulling that object down. And just like we're talking about falling parachutes in another video, the parachutist would have the force of weight pulling him down towards the earth, which would be his mass times gravitational field strength, and then in the other direction he'd have the air resistance, for example. So you need to remember that weight's a force that's measured in newtons, and you need to remember that weight will change depending on the gravitational field strength, whereas mass is measured in kilograms and mass does not change. So here's a couple of questions for you to have a go at using this equation here, W equals m times g. In the questions in the exam, they tend to give you this gravitational field strength value, so look out for that somewhere in the question. Remember to highlight the key bits and have a go on your own. Then pause the video and come back and see if you got the answers correct. So in the first question, if you highlight the key bits, the cat has a mass of 8 kilograms. Calculate its weight on Earth. So we're given the gravitational field strength up here. So we need to do weight equals mass times gravity. So weight equals 8, because that's the mass, times gravitational field strength, which is 10. So his weight is 80 newtons, remembering the units for weight. Second question, an astronaut has a mass of 70 kilograms. What would his mass be on the moon? Well, this is a bit of a trick question. You should remember from before that mass does not change. So if he's 70 kilograms on Earth, he will be 70 kilograms on the moon. Last question, a footballer has a weight of 800 newtons on Earth. Calculate his mass. So we've been given this time the W. We need to calculate the mass. This will involve us rearranging an equation, which is more likely to come up in higher. But if we start off with the equation W equals m times g, to rearrange that we need to make it m equals, because we need to calculate the mass. So if you divide both sides by g, we can have m equals W divided by g, which will, if we put the numbers in, we get m equals 800 divided by gravitational field strength, which again is 10 for Earth. So we get a mass of 80 kilograms for the footballer. So that's all you need to know about calculating weight. If you found this video useful, then please press the like button and feel free to subscribe. Thanks for watching.